Section 3.4 is linear programming. I chose number 17 to do, so I'm just going to walk you through the writing of the equations part, which you guys struggle with the most, and then I probably won't finish the whole thing, the plugging in the vertices, but I'll talk you through that a little bit. There's a company that's making two different kinds of backpacks. One's called the Journey and one is the Trek. And they tell us that a Journey backpack takes 4 hours of labor and makes $40 profit. The Trek backpack takes 6 hours of labor and makes $80 in profit. This company plans to make no more than 4 Treks and 15 Journeys. Find the minimum hours to make at least 400 per week. So remember, we're looking for what we want to minimize or maximize. Right here, we're going to minimize the number of hours. That means that is the objective function. So anything that has to do with how many hours it takes, that's going to go in the objective. I'm going to let Journey backpacks be X and the Trek backpacks be Y. So the Journeys take 4 hours of labor, so you could use H for hours, or we just default back to P. 4 hours per number of Journey backpacks plus 6 hours per Trek backpack. So this objective function you don't do anything else with until the end. We don't graph it. Now we have to go graph the inequalities. So you got your 2 gimmies that show up 90% of the time. We can't make a negative number of backpacks. So X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. It says you can make no more than 4 Trek backpacks. That's Y. So no more means you can make less than or up to 4. And no more than 15 Journeys. So X is less than or equal to 15. They phrased this one a little different. They said find the minimum number of hours, so we already used that, to make at least $400 per week. So this is a restriction. If it's something that you're limited by or you have to have an at least, that is one of your constraints. So the stuff that has to do with money, with our profit, if we're making money, that's a profit. So $40 for every Journey backpack they sell, 40 times X, plus $80 for every Trek backpack. 80Y has to be at least greater than or equal to 400. So here's our system of constraints. These are the ones that we're going to graph. And remember, we're doing the shading, the inequalities, so we're having the shading, and we're looking for that polygon that they make so that we can find the vertices. So here's my graph. X equals 0 and Y equals 0 means that it is in the first quadrant. So that's all that I've used on my graph is the first quadrant. So I have Y is less than or equal to 4. It's going to be below, so now I'm in this little rectangle. And X is less than or equal to 15. So now I'm inside this rectangle somewhere. This last one I'm going to graph using intercepts. So if I put 0 in for X and divide by 80, the y-intercept is 5. And if I put 0 in for Y to solve for X, the x-intercept is 10. And be careful with your shading, because normally you would probably shade right here, but it has to be greater than or equal to 400. It's this side. So it's actually this shape right in there. So we left off, I had graphed the feasible region. I went through and I found all of the vertices. So because I used a large graph and because I used a ruler and was careful, I could find the vertices just by looking at the graph. This one is 2, 4. Down here is 10, 0, 12, 0, and 12, 4. So the maximum or minimum has to occur at one of those vertices. So you have your objective function, which was p equals 4x plus 6y. For each of those vertices then, I plugged in the x coordinate, I plugged in the y coordinate, and I figured out what it was equal to. I evaluated it. So it asked you what was the minimum number of hours needed to make at least, what was it, $400 or something like that. So since you're trying to minimize, you look for the one that is the smallest. That's 18, so the minimum number of hours would be 18 hours.